Hello everybody, and welcome to the second page of assignment GG. This is some practice with non-geometric iteration, and we're going to a little bit of rehearsal with recursive formulas. It says for exercises 1 through 5, find the value of each expression. Then use that value as your next x in the expression. Repeat the process 3 times and describe your observations. So we're actually going to do 4 iterations for each problem. Okay, so for number 1, the function is square root of x, where x initially equals 5. So what we'll do first is plug 5 in. Square root of that is approximately 2.24. So what we do is next, do that 3 more times, as it says, we'll take the square root of each of those. Square root of 2.24 is about 1.50. Square root of 1.50 is approximately 1.22. And the square root of 1.22 is approximately 1.11. Okay, so and to describe what's happened, we just see these values. Values are getting smaller. They decrease. And that's generally what happens when taking the square roots of any quantity. The values go down, except for fractions, whole numbers, whole values, the values do decrease. Okay, number 2 is a little different. The function's 1 over x, where x initially equals 2. So if we just put 2 in for x, we have 1 over 2. Okay, so that's our first one. Here, I'll write this a little bit different this time. Then we're plugging in 1/2 to 1 over x. So what we have here is 1 over 1/2. 1 over 1/2 is written as 2. And then we're back to 2. Plug that in to 1 over x, we get 1 over 2. And then once again, one more time, 1 over 1/2, we'll get a value of 2. So these 4 iterations here, the values are just alternating. They're alternating between 1/2 and 2. Alright, and let's do number 3. Where 3 to the x power, where x initially equals 1. Well, the first iteration is just 3 to the 1, which is 3. And then we plug 3 into that. 3 to the 3 is 27. And then we start getting really big. 3 to the 27th power. 3 to the 27th power, if you do that on a calculator, there's so many digits that it has to convert to scientific notation. It is approximately 7.6 times 10 to the 12th. Now, attempting to do that one more time, putting that in for x, you can try that. Some calculators won't show it. There's so many decimals. But let's just say extremely large number. There we go. So obviously the values increase. And they get big really fast. They increase without bounds, so to speak. You might even say that they approach infinity. Alright, number 4 is pretty direct. X minus 5, where x initially equals 10. Okay, well that's easy. 10 minus 5, our first value is 5. And then we have 5 minus 5. Our next value is 0. And then 0 minus 5. Our next value is negative 5. Negative 5 minus 5. Our next value is negative 10. Okay, so values, what happens? The values decrease by 5 every time. Very simple. Okay, and for the last one here, number 5, x squared minus 4, where x initially equals 16. So we have 16 squared minus 4. That value is 252. Next we do 252 squared minus 4. And that value is 63,500. And then next we have 63,500 squared minus 4. Again, scientific notation, 4.0 times 10 to the 9th. And then that number squared minus 4. Such a big number, it's hard to, minusing 4 hardly affects the outcome. Scientific notation, 1.6 times 10 to the 19th power. And so once again we have